Welcome. My name is Nordling and I'm an assistant professor in automatic control at the Department of Mechanical Engineering at the National Shenggong University in Taiwan. I'm also the general chair of this workshop. Behind me I have the Department of Civil Engineering, which is housed in a building built in 1954 in order to house the Department of Architecture. Now, this building was designed by the faculty of the Architecture Department, and the sign down here was raised in order to commemorate this completion of the building. And now it's my great pleasure to introduce our honorary chair, Chair Professor Wu, that will welcome us all.
It is a pleasure to welcome all of you on behalf of the National Shenggong University in Taiwan. I'm proud that our team, the NCKU Parkinson's disease quantifiers, are one of the finalists in the OpenCV AI competition. They are also arranging this workshop. Now let us all learn computer vision and AI using the OD camera together.
Hello and welcome. I am Akram Ashiani, postdoc researcher at the Department of Mechanical Engineering of National Shenggong University and assistant chair of this workshop. It is my honor to introduce Mr. Jagmohan Meher, an engineer in robotics and a passionate teacher. Heading the Research and Development Department of Skyfi Labs, he has worked on different technologies like computer vision, robotics, mechatronics, Internet of Things, and machine learning. He will present computer vision in robotics and teaching OpenCV to beginners to teach OpenCV by building a project which is a color-based object detector using OpenCV. While learning from the tutorials, you could practice the code on your system using almost any camera.
Hello, ni hao, hola, namaste. I am Jagmohan Meher, and today we are going to learn about computer vision in robotics and how to teach computer vision to beginners as well as school kids. So let's begin. It's going to be something interesting for all of you. I know people are from all across the world. There are beginners. Some of you are already experts in computer vision. But let's take a look at how to do computer vision in a good way. So computer vision in robotics and teaching OpenCV to beginners. I am Jagmohan Meher. So first of all, let me tell you the objectives. What is the agenda of this whole program? So my session is divided into two parts, day 1 and day 2. In the first day, we will learn some basics of computer vision and some pedagogical tricks of how we can teach computer vision or a complex thing like programming in Python to beginners. On the second day, using the concepts that we have learned and learning some advanced concepts in computer vision, we will try to build a project which is called color-based object detection using OpenCV. We are basically building a simple robot which will be able to detect an object which based on its color, right? So let's begin. First, let's connect and then share. So this statement is very important when we come to teach, right? So let's first connect and then let me share my knowledge with you. I would like to introduce myself. I am Jagmohan Meher. I work as a robotics engineer and educator at Skyfi Labs. So Skyfi Labs is an organization which works on building courses which are completely hands-on, and they are of variety of technologies like mechatronics, robotics, computer vision, IoT, AI, machine learning. And we try to deliver it online and through offline mode also to school-going kids as well as those kids who are attending university. My role was to develop new projects, develop new robots, develop new courses, and also to develop pedagogical tricks and methodologies of teaching. I have had the privilege to teach a variety of kids, like thousands of kids and students, students who are of age 6 to students who are of age 60. So having this broad experience of teaching, I would like to share my knowledge with you, and I would like to share my experience with you on computer vision as well as on how to teach. I hope my thoughts and my ideas are insightful to you. The most important thing about teaching, or the most important way to begin teaching, is to form a bridge. Suppose you want to teach a particular concept or a particular topic to a student. The student doesn't know the topic. The student doesn't know why is the student learning the topic, right? It is the responsibility of the teacher to explain why are we teaching this topic, as well as before we transfer the knowledge, we have to establish a connection between the student and the teacher. That's what I mean by forming a bridge. I know that it's very difficult to form a bridge in a video like this, but I will try my best. But if you are with a person or with a group of students, you can form a bridge by trying to understand them, by asking questions and sharing about yourself. Once the bridge is formed, the knowledge transfer happens very easily and effectively. Now, let's begin our today's topic on computer vision. What are we going to learn in computer vision? We will learn what it exactly is, what are the applications, and if we want to do computer vision, how are we going to do it, and what are the tools we are going to use in computer vision. Let me begin with a story. We all must have seen this video, and the Tokyo Olympics 2020, Japan has built a robot that is shooting basketballs, and it works. That is the amazing thing. And let's take a look at this video for you to understand it better. You can see that a robot is shooting basket from the three-pointer area as well as the logo area, the mid of the court, and it is able to shoot perfectly. It's a pointer. Let's try to ask a question here. How is the robot able to notice that the basketball is there? It is going and picking up the basketball. It is looking at the basket, and it aims the ball towards the basket and it throws it, and the ball enters into the basket. A lot of complex things happening, right? But here is the beauty of computer vision. And there are a lot of other technologies which are inbuilt into it, like mechatronics, artificial intelligence. But today's topic is based on computer vision. So let's try to understand what kind of vision this robot has. This robot can detect the basketball. It can detect the basket. It can know what is its position in the court. It can aim the ball towards the basket, measure the distance between itself and the basket, find out what will be the best angle of shot, angle of trajectory, and it shoots with the accurate amount of force. So it has a very smart vision. Let's take a look at what is a computer vision. Computer and vision, a machine which we are trying to give our human vision system, is called as computer vision. Very simple to understand, but it's something very complex to implement. We will learn it in the process. High-level understanding of computer from digital images and videos. So computer vision involves processing of digital images and videos so that it can make real-time decisions. Let's take a look at what are the different ways we can use computer vision. Many industries and many people use computer vision in their own ways. Let's take a look at a few of the examples. For example, machine vision in factories, in industries, same product is built 1,000 times. Now, if we ask a person to stand there and keep on checking the quality of that product, there might be some errors. But if we implement a camera system that will keep recording the video and keep analyzing if there is some defect in the product or not, then it will be a much efficient way to do a quality check. Object identification and tracking. You can notice in this small image over here, there are lots of people, there are some lamps, there are some statues, and this image has boxes around them. It can detect if it's a person, it can detect if it's a statue. That is called as object identification and tracking. Now, we are also going to build something like this. We are also going to build a project in which we will be tracking objects based on their color. If you are trying to track an object of yellow color, it will put a box around it. We'll learn about it. Detection of events. It is similar to object identification and tracking, but on a continuous basis it happens. For example, in zoo, national parks, in forests, we want to track what is the motion of the animals, what kind of motion they take or what path they take generally, so that they do not enter into a dangerous place, so that they don't harm others and they don't get harmed, they don't enter into human settlements. In this way, we can prevent a lot of disaster from happening. Similarly, in malls, in airports, in markets, we try to analyze the customer behavior, the movement of the customer throughout the market, so that we can place the shops at the exact location where there is more crowd and we can attract more attention. Some kind of marketing strategy. Human computer interaction devices. This is one of the most interesting things that is coming up. Education is going to be transformed from a video platform to a virtual reality platform. Nowadays, there are a lot of companies who are teaching biology, mathematics, science using VR glasses. Not only that, a lot of gaming is also happening on virtual reality, and it's literally very, very amazing. Mapping of environments. In army, before they enter into an operation, they need to analyze the enemy territory. How do they do that? They will look at maps, they will look at the contours of the map, they will look at if there is a mountain, are there houses over there, are there shops over there, they will try to analyze the place. That was happening many years back. Nowadays, they have a very smart technology. They will send a drone above the place. The drone will record a lot of images and videos. And finally, using computer vision, they can make a 3D model of the whole environment. It becomes easy for the army to understand the enemy territory and to decide a great plan of attack. Autonomous navigation, one of the most favorite things of every person. We all want a car, so we don't have to drive, right? We just have to open the back door, enter into the car, close the door, and just tell the car, I want to go home, take me to the office, take me to the market, and it will automatically drive you. You can sleep, you can do whatever you want in the car, and it's really amazing. Now, how does it work? It works based on computer vision. Here you can see in the image, this car is able to detect the other cars, it is able to detect the road, and it has multiple algorithms of computer vision running inside it. So these are a few applications of computer vision. And if you have any application in your mind, if you want to build an application of computer vision, then let's begin and let's learn the basics so that you can start working on it and you can build your own applications. Let's try to understand what is the computer vision pipeline. The question is, how are we going to do it? The first and the foremost thing is image acquisition. Like I told you before, it deals with image processing. So first thing is we need an image. And once we acquire the image, how do we acquire the image? By a camera. You can see me, there's a web camera in front of me and you can see me, right? So this is the image that you're able to see. Now it seems like a video because there are many images playing one after the other very, very fast. We will learn about that. Image acquisition is the first step. Now, once we have acquired the image, we will try to process it because the image is like a raw material. It is not in a form that we can use it. So we will try to process it and then we will analyze. Some part of the image is of our use, some part is absolutely unnecessary. So we have to focus on those parts, those minute details of the image that is valuable to us. And based on this analysis, we can make a lot of decisions. We will be learning the whole process in a very practical way once we are doing the color-based object detection using OpenCV. But let's take a look at how are we going to do it. We are going to use some tools. OpenCV stands for Open Source Computer Vision. Open source means it is freely available. You can search for its documentation on the internet, and there are a lot of blogs, a lot of articles, a lot of YouTube videos which explain computer vision in a great way, right? Now it was developed in C++, and we can, if you know Python, if you know Java, MATLAB or Octave, these are the 4 softwares which support computer vision, and we can implement computer vision on these platforms, right? Now, to begin with, let's take a look at the absolute basic idea of computer vision. We are going to talk about an image. So what is an image? What is a pixel reference? What are color spaces in image? Let's take a quick look at these things. And what is a video? Once we understand these things, then we will start with some practicals and we will see how to use computer vision on Python. What is an image? You all know it very well. But what is the most basic element of an image? It's called a pixel, a picture element. Multiple picture elements are combined together to form an image. For example, take a piece of paper, draw straight vertical lines on it, many of them. Draw straight horizontal lines, many of them. And then, if I give you a task, you have to darken the boxes so that it will form an image. That is called an image. I hope you understood the reference that an example that you can see over here. Now, in technical terms, an image is a 2D matrix, 2-dimensional matrix having a function x and y, which has multiple rows and multiple columns. Now, it has 2 aspects to it. It has multiple rows and multiple columns, so there are many boxes which are called as cells. Now, every box has a spatial coordinate. We can find out what row it is on and what column it is on. That is x and y. And every box will have some intensity of a color. So the intensity of a color is always ranging from 0 to 255. Remember these 2 numbers, 0 and 255. We will learn about these things in the practical session more. What are these colors? Now, what is a pixel reference? Here, like I said you, suppose we want to take this particular cell. It is on the 3rd row and the 4th column, and it has some intensity inside it, and which can be a number from 0 to 255. And it's a 2D array matrix which has 2 dimensions, x and y. A black and white image is a 2D matrix. Okay. Now, a colored image. We used to watch black and white movies long back, and those were quite simple, but people got bored with it and they wanted to watch something more colorful. And when colored movies came into the cinema, it was absolutely fantastic because we could see everything. What we saw in real life, we could see on the screen. That was so amazing. Now, on this hand, you can see this is a 2D matrix. It has 2 dimensions. This one is a 3D matrix. It has 3 dimensions. Red, the third dimension is red, blue, and green. Okay. So a 3D array or 3D channel is corresponding to a colorful image. Okay. So it has 3 channels, red, green, and blue. Let's learn more about it in more details. Now, every color, here comes the interesting part. Every color is an 8-bit element. So there are 3 primary colors, red, green, and blue. Here we take an example. Suppose we have a pixel and we want to give it a high amount of red and high amount of green, but a low amount of blue. So here you can see this is blue. It's 0, green, it's maximum, that's 255, and red, again, it's 255, right? So the final color that we get is yellow. Okay, yellow is a combination of red and green color. Okay. Once we do the practicals, we will see how exactly is it working. Now, color models, there are different ways to represent color. Okay, there are 3 major ways of doing it: RGB, red, green, and blue; HSV, and CMYK. Okay, so we will be focusing on RGB and HSV more. Let's take a look at RGB. RGB is very, very simple. It's a color model which is very common. We focus on the primary colors. Okay, so the primary colors are red, green, and blue, and we represent it with these 3. And when we combine all 3 colors, it becomes white. When we combine red and green, it becomes yellow. When we combine green and blue, it becomes cyan. When we combine red and blue, it becomes magenta. Okay. But the interesting or the technical part that we have to understand over here is it is represented by 3 channels. Each channel consists of 8 bits of information. So if we want to choose a color, it will be of 8 bits of information. Remember that, from 0 to 255. Now the second model of color is HSV, hue, saturation, and brightness. Over here you can see the image which explains what is hue, saturation, and brightness. Hue is the actual color, and here you can see it's blue and a little bit white, yellow, green, yellow, and all the colors you can see on this is the hue. Saturation is amount of gray added to that color. Okay, so you can see from the center as we go far away, the color becomes more dark, or the amount of color increases. We are adding some gray to it. Value means the amount of white added to the color. Okay, you can see the value is increasing upwards over here. And on the bottom part, you can see it's very dark. But as we go up, it becomes brighter and brighter. So the amount of white added to it. Okay, so it is useful for color-based operations and color manipulation. Now, just like RGB has a technical term which is represented by 8 bits. Here, HSV is slightly different. Hue is represented by an angle 0 to 360 degree. If you notice, it's a circle, and from 0 degree to 360 degree, we can find out what is the color based on the angle. Saturation and value have a percentage. From if it is 0, that is the least, and 100 is maximum, and obviously it has again 3 channels. Okay. Now, having understood what is an image, let's take a look at what is a video. We all watch movies. You are watching me live on a video, right? So what is happening? My camera is recording images. It is taking snapshots so fast, maybe 60 snapshots in 1 second. Okay, and it's playing these images one after the other, which is called as frame. So it is playing the images frame by frame. Now, video is a representation of moving visual images. What is frame rate? It is number of still images per unit of time, per second. So typically, generally, the frames per second is 24 to 60. And aspect ratio, the size of the screen. There are different sizes, or there are different ratios in which different types of screens you can see. Here are some examples of them. Okay, so having understood the basics of the image and video and what is computer vision, let's take a look at some practical part. So now we are going to open Python and we will be doing some practicals on Python. Okay, so let me open the IDE. I'm going to use Python 3.9, that is the latest version of Python, and let me share my screen with you. Here it is. If some of you know Python, that's very good. If you do not know Python, don't worry. It's a very simple language to learn and all of you can learn it very easily. So I will open a new file and let's begin. The first thing I would like to do is let's get an image and let's display it. Okay. Now to do this, we need to write some code. So first of all, I would like to import a library. In Python, we have to install the OpenCV library so that we can use the different functions it has. So the keyword uses import CV2 as CV. It is the library name is CV2, but I will refer to it as CV. And there is one more library that I would like to import, which is used to make matrices. Import NumPy. Okay, very simple. Now we are going to acquire an image. Okay, so for that I have to declare an object or a variable. img. Let me take a variable called as img. And I will use the command cv.imread. Now, what image am I going to read? I have an image for you. That is called hazard10.jpg. Okay. Now, this is an image that I have already saved. Let me show it to you. I have it over here in this folder. Here it is, hazard10.jpg. You can see this is an image of the football player, one of the finest football players I feel, Hazard. And let's go back to the code. It's not the code. Here it is. So I will try to import that image and I will try to display it. To display it, I will write a command cv.imshow, image_show. And it will show it in a frame. So I have to give a name to the frame. Okay, so let me just call it image. And the second argument is the particular variable in which I am storing the image, img. Okay, so first step, I am importing an image. Second step, I am displaying it. Now, how do I end this? Suppose I press any key on the keyboard, the window should vanish. So what I will do, I will write cv.wait key. Okay, cv.wait key, it will wait for a key to be pressed. And once the key is pressed, it will destroy all windows. Okay, destroy all windows. Now, the code is ready. First of all, we will save it. To save it, I am going to save it in the same folder of that as in which the image is present. Okay, so I have it in my desktop. It's in computer vision, and I would like to give it a name called as image read.py, py, so that I can store it as a Python extension. Okay, now to run this code, I will click on run and run module. Let's see what happens. Here you can see I have the image. So this is the image. This is our football player. This is our football. And here we are. Now, how do I close it? I can click on the close button, but I will do a press. I'll do a click on the keyboard and it will vanish. Oh no, there is an error. Now see, the interesting part comes over here. I have designed the code, it's working, but still it gives me an error. So what is the error over here? If we think, it tells us actually what is where is the error. CV dot destroy all windows. I guess there is a spelling mistake over here, right? So let me write it destroy all windows. Okay, I will save it and I will run it. And here we are. Now I'll press a key on the keyboard. It vanished, right? So what we can understand over here, we have understood what is happening in the program, but let's understand in terms of teaching perspective what I did right now. I am trying to give you an example of what we have learned in theory. So whenever we are teaching something, it is very, very important to present it in a practical way so that the ideas can be etched into the mind of the students. And another important point over here is don't be afraid to make mistakes. I made a mistake over here and I feel absolutely okay to make mistakes. Why? When a student sees that a teacher is making a mistake and is willing to rectify themselves, is accepting the mistakes and willing to rectify, they feel a connection with the teacher. Trust me, this has worked. This particular trick has worked wonders for me. And it is absolutely important for every one of us to understand. If you are teaching something to someone, do not be afraid to make mistakes because they're human beings and it's okay to make mistakes. But be willing to accept it and rectify it when you can do it, right? Another very important thing, like I told you before, give a lot of examples while you're teaching the concepts and give examples which are relatable, something that they might have seen before, something they might have experienced before, so that they can connect the idea or the concept to their previous experience, which will give them an opportunity to remember it for a very, very long time. I hope you're able to understand what I'm saying. Now, let's come back to computer vision and let's take a look at what else we can do with this. We saw that hazard10.jpg is a colored image. Now, suppose I want to make it black and white. I will do here comma 0. So cv.imread, I'm writing the name of the image, comma 0. Let's see what happens. Oh, you can see this is a grayscale image, right? Now, it happened in a very organic way, but let's take a look at how we can actually do it using code. So let's let me just remove the 0 from here. Okay, so we have hazard 10. Now let's take a let's learn a new thing about the images. Let's do some basic operations on the image. Suppose I want to convert the color of the image from BGR. Generally it is BGR, okay, blue, green, and red, to grayscale, or I can convert it to HSV. There are 150 different kind of transformations that you can do, but we will stick to some basic stuff. So IMG gray is equals to CV.CVT color. CVT color means convert color. Now, the interesting fact over here. Whenever you are learning Python or computer vision, it becomes very simple, because here you can see whenever I'm typing a command, it will show you what exactly that command is about. And there is also a documentation that you can refer to, which I will show you in the next class. You can refer to that documentation and that will help you to learn all the different kind of keywords or functions that the OpenCV has to offer, right? And based on this thing, we'll be able to learn a lot of new things. Okay, so let's take a look at this. So CVT color. Now, what is the image? SRC means source, and this is the code or the kind of conversion that I want to do. I want to convert the IMG and I want to convert it into CV.color underscore BGR to gray. Okay, CV.color BGR to gray. Now I want to show both the images. Okay, I want to display both the images, but I will name it as image 1, and this will be image img underscore gray. So I will present both the images. Let's see how it looks like. Here we are, two different images, with one is BGR and the second one is grayscale. Now suppose I want to convert it into HSV. What do? I will copy it and paste it so that it becomes fast. And IMG HSV, and here I have to just change this one BGR to HSV, and again I will copy and paste this one so that I will get a third frame, image 2, and this will be HSV. Okay, so I'm displaying three different images in three different color spaces. Let's take a look at this. Wow, this is something interesting, right? Here we have the BGR, here we have the black and white, the grayscale image, and here we have the HSV. I know you might not have expected the HSV to be like this, but yes, it is. And let's go back. Now, what are we going to do next? We will try to split the image. Now, we learned that one image has got three channels. It's a three-dimensional matrix. It has red, green, and blue. So we will try to split all the three parts of the image, and then we'll see what it looks like. Okay. So what I'll do is I will comment these things so that these things don't come in our comment out. So these things don't affect us. Now I am going to use something like this: B, G, R is equals to CV dot split. Now see, we have CV dot split, and what am I going to split? I'm going to split the image IMG because IMG has three channels. Okay, but how do I know? How do I actually know that IMG has three channels or not? Let's take a look. So I have something interesting. So let me print something over here. If I print CV dot size of IMG, okay, and if I print CV dot shape of IMG, let's see what happens. If I'm getting something, oh no, sorry, there is a mistake over here. Now what can be the mistake? The mistake is in the syntax. This is not the right syntax. I'm going to use img dot size, and here I'm going to use img dot shape, right? And let's take a look. There's again a mistake. Oh, just let's do it once again. But there is something over here that we can change, and let's try now. Yes, so here you can see this is the size of the image and this is the shape. Three channels. So these are the number of rows, number of columns, and 3 means there are three channels: red, blue, and green. Okay. How did I come to know about the mistakes? I referred to the documentation. Okay, and I will show you the documentation in the next session that is happening tomorrow. But now, once I have done this, let's come back to the splitting of the image. And in the splitting, we have to display these three things, right? So let's see how we can display. So cv.im show blue, and I will give B, and to make it faster, let me copy it paste and paste. The first one is blue, and then green, and then red. And I will change this to G and this one to R. Okay, let's see. I will show it to you. So here we have three different images: blue, green, and red. But it doesn't look exactly like blue, green, and red. We could never have imagined that it looks like this. But yes, it might not look exactly like blue, green, and red, but it is how these are divided. Okay. So this is how we can do some basic operations on the image. And now let's take a look at how we can capture a video. So to capture a video, let's go to a new file. We are going to do a project in which we are going to track an object based on its color. So a video will be running. And so what is a video? It is a collection of images played at a faster rate. Okay, so we will now record a video. For that, I will import CV2 as CV, right? And then import NumPy. Some people call it NumPy, some people call it NumPy. It has different pronunciations. I like to call it NumPy. And here we are going to use an object cam equals to CV dot video recorder, video capture. See, now when I write video, it gave me different options. There are actually different options of video that we can do. But for me right now, I need video capture. And now we are going to use this object cam to record the video. How? Now a video has to be continuous. So we will take an infinite loop. I'll use the while loop and I will give true, so that it becomes an infinite loop. It will keep on going. There's no condition. It will keep on running. I will give the condition for the loop to stop inside. So here ret comma frame is equals to cam dot read. So I have a web camera over here and I am giving it a command to read, to capture the image, and I'm going to store the image in frame. Now once this is done, I will try to display it so that I can see myself. CV dot I am show. As the image is going to be stored in the frame, I will store it. And I have given the variable frame. We are going to display the frame, right? Now, how do I end the video? If I press escape button, then the video will end. So if, wait, before that, key is equals to CV dot wait key. If you remember what is wait key is a command which will wait for a key to be pressed to take some action. Okay. So here, whenever a key is pressed, whatever key is pressed, we are going to store it in this particular variable. Okay, suppose I press A, this variable will store A. But if I press escape, this variable will store escape. Now, if key equal to 27, now this is the ASCII code of the escape button, 27, remember it? Then I will break from this loop. Break means it will come outside of the loop. It will break out from the loop. And again, I will do cam.release. Cam.release, what it will do? It will stop or it will deactivate the camera. It will release the camera. And then cv.destroy all windows. Okay. So here we are, and I'm going to save it in the same directory, but I will save it as capture video .py. Always remember add .py at the end so that it becomes a Python file. You can see the type, it's a Python file. And let me run it. Okay, we again have an error. Let's go back to the code. Whenever an error comes, I get very excited. So what is the problem? CAPUTRE, there's a spelling mistake, right? CAPTURE. So again, a pedagogical trick. Even if you do a mistake, it's absolutely okay, because if you do a mistake and if you accept it, the student will have a better connection with you. I'm telling that out of my experience. Let's save it and let's run it once again. Oh, yes. Okay, what is the problem? I don't see my video. It's a blank screen. There must be some issue. So I will close it. What is the problem? It says cv.imshow frame. So there is some problem in this particular function. Okay. Now, to understand what is the problem, we will go back. And here in the video capture, we have to mention 0. What will 0 do? It will take the first camera. I'm using a laptop, so it has a camera on it, and that is the first camera. We can connect second, third, fourth camera, as many cameras as we want. Excuse me. And we can use them. Let me save it and let me run it. And let's wait for it. Okay. Still, there is some error. Well, it again says that cv.imshow. The error is over here. So let's go back and let's find out where the error is. So I am guessing the error might be, it could be in this one, I guess. Let me just run it once again. And let's wait for it. Still, there seems to be an error. I am guessing that my Zoom is already using the camera, and I guess that is the reason it is not able to show the camera. Let me just check it. Okay, so I have turned off my camera so that I'm using the Zoom software and it shouldn't affect it. So let me just run it over here. I've stopped my camera on the Zoom app, and let's see when I run it, will it show me my video or not? There it is. So here we can capture the video. This is the frame, and inside it we are getting I'm getting my video. Okay, so let me press escape and it vanishes. I will turn on the camera once again. So here it is. And so this is how we are going to do programming. Now let's go back to the PPT. So let's take a look at what all things we have learned. So we are towards the end of the session, and towards the end, I would like to just recall everything that we have learned. We learned what is computer vision, different examples and applications of computer vision. What is an image? What is a video? We learned how to read an image, how to import an image, change the colors of the image from BGR to HSV, from BGR to grayscale, how to split the 3 channels of an image into blue, green, and red. And we also learned how to capture a video, right? So these are a few things that we learned in OpenCV. What are the pedagogical tricks that we learned? We have learned some interesting things, like when we begin our session or when we begin teaching, we should first connect and then share. Unless a bridge is formed in between the teacher and the student, it is absolutely impossible for knowledge to be transferred. Now, start with a story or an example. Do you remember what story I started with? The Tokyo Olympics 2021, the robot which is throwing the basketball. That's an interesting story to start with, and I felt really excited to share this story with you. Now, explain the concepts with relatable examples. Throughout my whole session, if you noticed, whatever things we learned what is an image, we learned what is a video, and we also learned how to read an image in a practical way. What are the different channels of color, the 3 channels that we learned about. We saw it in a practical way. How to capture a video, we saw it in a practical way, right? So I have always tried my best to explain the concepts in a very relatable with relatable examples. and add a few personal stories. If you noticed, I have been adding a few small stories that might be of your interest. What it does is it brings back your attention to the whole session. Suppose sometimes what happens, you are watching a video or you are listening to a lecture and your mind wanders, not yours, the student's mind will wander around. To bring back the attention, we need something personal, something that will capture their attention. So these are a few things uh, that will, these are a few pedagogical tricks that we have learned, and we will learn more in the next session also. Plus, I would like to share with you the secret sauce. You know, when a cook is cooking, some cooks are so good that everyone would love their dish, but there is something secret about them. The secret sauce or the secret ingredient is smiling. Whenever you're teaching, if you smile, if you give that warm smile, everyone or all the students will connect with you very easily. Why? Because it is something psychological that has that has been hardwired inside our brains since millions of years. A smile always gives a sense of warmth, a sense of belonging, a sense of openness. So when you smile, you show that you are accepting them the way they are. You are curious to know about them. You're curious to teach about this particular topic. That's why keep smiling and keep teaching. I would like to thank you very much for listening to me with patience, and I really appreciate it. I will see you in the next session. Thank you so much.
Hi everyone. The second part of Mr. Meher's presentation will be streamed at tomorrow 1 p.m. and the Q&A session for Mr. Meher will be after that. We'll be back at 3 p.m., so it's roughly 8 minutes. And after that, let us enjoy Professor Lin's presentation together. See you guys later.